Hey guys, you wish to enter the Web3 space? You want to break into blockchain? But do you think you don't have the basic understanding of some of the core concepts or the fundamental concepts of blockchain? Then don't worry. I'm here to help you. I'm Jobin, the developer evangelist at Arcana Network, and today in this video, I'm going to help you understand some of the core concepts of blockchain, such as what is blockchain, how it works, consensus, what are smart contracts, what are dApps, and how Web3 space works. So without any further ado, let's dive into the basics of blockchain. So if you go out on the internet and search for what exactly blockchain is, the simplest definition that you can get is a blockchain is a public chain of blocks containing data. The visual representation here shows cubes or block-like structures that are connected to each other. And going by the definition, each of these blocks or cube-like structure stores some sort of data. This is simple, but let's make it more simple and easy to understand using something that you're already familiar with. So, in simple words, a blockchain is like a sequential chain of coaches and tree. Would you be surprised if I tell you blockchain looks and works exactly like a train? Yes, that's true. So the visual representation here shows a train containing engine, coaches, and coaches containing passengers and its other set of features. So let's understand the similarities between a blockchain and train in detail. So the first most important similarity, what do you see in train? Trains have got multiple coaches that are connected in an order. Okay. So these coaches are arranged in like order like A1, A2, B1, B2, or probably S1, S2, S3. So there is some sort of order in which these coaches are arranged. Okay. So it's arranged in a sequence or in an order. Similarly, instead of coaches in blockchain, we have got something called as blocks in blockchain. So blocks are arranged in a sequence or order in a blockchain. Okay. So that is the first important similarity. Second similarity is that actually the first coach and train is called as engine. Engine is what pulls all these successive coaches in a train. Okay. So instead of engine in blockchain, we have got something called as Genesis block or the first block, or even you can call it as zeroth block because it is called as block zero. So what does this word Genesis mean? So Genesis means the beginning block. So the beginning block is called as the Genesis block. So instead of engine, we have got Genesis block. Third similarity is that while you get a ticket to travel in train, you will see that it mentions each and every coach has got some naming or identification like S1, S2, A1, A2, some sort of identification. So for you to easily identify each and every coach without confusion and travel in this train, each and every coach has got some sort of identification number. So like S1, S2, or A1, A2. Similarly, for you to easily identify each and every block in this entire series of block in blockchain, you've got something called as hash of the block. So hash of the block is nothing but it's a combination of numbers and letters. Okay. The example I can show you here is the visual representation right now on the screen shows Genesis block containing a hash called as 1Z8F. Okay. It's a four-lettered hash. Actually, the length can vary. It can be more than this. Okay. So, but it's the concept behind this is that it's a combination of letters and numbers, and it's unique to each and every block. And this is what is used to identify each and every block in a blockchain. Okay. So instead of coach numbers, we have got hash of the block to identify each and every block. Next one. So for you to understand the continuous order or the sequence or the series in which these blocks are arranged in an blockchain, you need to know which block is the previous block and what's the next block. Like if you're in a train, you might be in a coach number B2. Then if you want to understand the order, somewhere you need to look for the identification, which is the previous coach and what is the next coach. So you can see at the door or entry or exit points, there might be identification showing the previous coach is B1, the current coach is B2, and the next coach is B3. So this helps you understand the entire order in which these coaches are arranged in a tree. So similarly, for you to understand the order or the sequence in which these blocks are arranged in the blockchain, each and every block also stores the hash of the previous block. So this helps you form a continuity or a sequence. Okay. Next what? This is the most important similarity, and this is why we use a blockchain. Okay. Why do we use train first? We use train so that people can travel from one place to another place. Okay. Or it can be for transportation of goods also. So similarly, a blockchain is used to store data in this block, and you can share this data from one place to another place on internet. So instead of passengers in train, we have got data that has been transported from one place to another place on internet. So this is what basically is the similarity between a blockchain and a train, and this is why it looks and works similar. Okay, next what? How is a block created? How is a block added into a blockchain? Okay, so let's first understand the similarity between the creation of coaches in train and use that to understand the process of creation or adding a block into a blockchain. Okay, back in 1800s or 1900s when actually train was introduced, the number of coaches was very less because at that time very few people used to travel in train, or a very few amount of goods need to be transported from a location to another location. But as time moved on, the demand or the requirement increased. So the organizations or the government running this train had to manufacture new coaches and had to add that into the train. Okay. So basically, there is a template or a structure that has to be followed in the process of creating or manufacturing this train. Okay, like how many doors, how many number of doors it should have, how many windows it should have, what is the structure in which the seats should be arranged, all these things. Okay, so the organization basically gives this template, and using this, the manufacturing facility manufactures or creates these coaches. Okay, and there's some sort of work involved in this process, and this work is mechanical work. So in the similar fashion, a block is created for blockchain following certain structure or template. What is the structure? It's very simple. A block should contain data. That is the most important thing. Second is it should have its own hash of the block for easy identification. And also it should store the hash of the previous block. So if we had 10 blocks in a blockchain, and if you're creating or adding the 11th block into a blockchain, then you should also store the hash of the 10th block in your 11th block. Okay, so these three things are the important things that you need to consider while creating a block. And there is some sort of work involved in this process, and it's called as computational work, because you use your computer's power to create or manufacture this block and add this into a blockchain. And instead of calling this manufacturing, we can call it as mining. Mining is the process where you combine the computational work and follow the structure to create a block in a blockchain and add it to this series of blocks. Now you know how a blockchain looks and works like. But why are we even discussing about blockchain? Why is it even a topic of discussion? It is because blockchain is a game-changing technology. So why is blockchain a game-changing technology? Let's understand it first. It is because of the OTP nature. Sounds different? Let's understand what OTP is. OTP, O stands for open, T stands for transparent as well as trustless, P stands for privacy as well as permissionless. So let's understand each one of them one by one. So it's this features are what makes blockchain stand out from other technologies. It's what makes blockchain unique. So what's open? What's the open nature of blockchain? Blockchain is open. That is, it's not like typical database or typical technologies where the entities running or hosting it can restrict the users from accessing it or using it. Blockchain as a technology is open to all. Anybody can access or use it. Anybody can deploy applications on this network, run programs on this network. It's open to all. No single central entity or any entity can control or restrict you. Anybody on this network can use this blockchain technology. So it's open to all. Next one, T. T stands for transparent. Blockchain as a technology is transparent. Whatever is happening inside this technology or inside this network, it's completely visible to all. Anybody on this network can view whatever the activity that is happening inside this network. The best example that I can tell you is Bitcoin. Bitcoin was revolutionary because it was a monetary solution. And whatever the monetary transaction that was happening inside this was completely transparent, all thanks to blockchain. So nobody could do frauds, scams, because anybody could verify these transactions that was happening on this network because it was transparent. Similarly, whatever the activity that is happening inside this network, it's completely transparent. So anybody or everybody can verify it, ensuring that it's completely safe. Next one, T also stands for trustless. That doesn't mean blockchain doesn't have trust. It means that there is no need for trust. You don't have to depend on anybody or any entity, or you don't have to trust them. It is because of the fact that blockchain uses something called as smart contract. That means all the activities that is happening inside blockchain is automated. No entity is controlling or running it. You don't have to depend on any entity or any person. Once it is pre-programmed, that once it receives a certain input, it can give you the output. So you don't have to trust anybody. Whatever is the requirement, you can trust that it will be given. Next word, P. P stands for privacy. It's transparent. At the same time, the users doing this transaction can stay anonymous. They can safeguard their identity. So this provides privacy. And it is all thanks to complex cryptographic algorithms that certain things that you want in blockchain network can be kept private, such as your identity. The other P stands for permissionless. It's like trustless. You don't have to take any permission from anybody or any entity to get your things done. So if you're, example, if you're building blockchain based Netflix or Amazon Prime, so you don't have to get permission from Netflix or the Amazon Prime or similar entity to get your movies or series downloaded. Once you pay the fees as an input, automatically it is programmed to give the output. That is, give you the option to download or watch the series or movie. So you don't have to take permission from anybody. It's completely automated. So all these features are what makes this blockchain technology so sweet, so revolutionary, so game changing. And all this is thanks to something called as decentralization. What is decentralization? Our traditional applications run on a couple of servers, usually managed by some central entity. They have complete control over it. They know what exactly is happening inside this network. They can monitor and manage it. But in contrast to that, a decentralized network is not powered by servers controlled by central entities, but it is powered by huge number of nodes distributed across this world at various geographical locations. So this prevents dependency on any central entity and their servers. And because of the fact that huge number of nodes are powering this, it faces less downtime. It is more reliable and robust. Whenever you want to access your application running on a decentralized blockchain network, it will be readily available. And also, blockchain has consensus implemented here. This ensures that the entire network and whatever is happening inside this network is tamper proof. Nobody can manipulate anything on this network. Blockchain is a decentralized system, right? Then how is decision taken in blockchain without any central entity or central authority to take decisions? So what exactly is consensus? Consensus is a technique through which a group of people come to a common agreement using majority. Let me make it simple. So consider you have a group of 5 friends. You all want to watch a movie today. In the theater, there are 2 movies playing today, movie A and movie B. So if out of 5 friends, 3 decide that you all want to go to watch movie A, then you go for watching movie A today. And whatever the opinion of other 2 people out of your 5 friends are, it is neglected or it is ignored because they are minority. So the opinion of the majority is considered to make decision. Similarly, in consensus that is involved in blockchain, instead of friends, we have got entities called as nodes who power the entire network, and whatever their opinion is, whatever the majority of the nodes' opinion is, that is considered as a factor for making decision. Okay, so there are various techniques through which consensus is achieved. So let's study a couple of them. A couple of commonly used consensus techniques such as POW, POS, DPoS, and many more are there. Let's understand each one of them. So POW, what is POW? POW stands for proof of work. So the decision that is taken through consensus is basically whether a block should be mined or not, or whether a block should be added or not, or whether a block is right or wrong. Okay, that is what the decision is taken through this consensus mechanisms. So basically, through proof of work, you have to do some sort of work and show its proof. Once you give its proof, then you get a chance to add that block into blockchain. Okay, complicated? Let me make it more simple. Consider you are a teacher in a class of students and you are on a Sudoku contest today. So you share a Sudoku puzzle with all of your students and you have a leaderboard on the board. Okay, so whoever is the first student to solve the puzzle and come and tell you that he or she has solved the puzzle becomes the winner. So nobody else who solves the puzzle after that student gets a chance to become the winner. Only the first person to solve the puzzle gets a chance to become the winner. Okay, probably he or she will get a reward from your end also. Okay, so the opportunity to become a winner depends on the factor whether you are able to solve the puzzle and whether you are the first one to solve it or not. Similarly, in blockchain, in proof of work consensus mechanism, you get the opportunity to mine or add a block into blockchain depending on whether you are able to solve this puzzle first or not. If you solve the puzzle first, then you get the opportunity to mine or add the block into a blockchain. Okay, but the puzzle is actually not a puzzle like Rubik's Cube or a Sudoku, but it's rather than that, it's a complicated computational puzzle which is solved using computational power involving a lot of computational resources. So your computer solves this computational puzzle, and if your computer is the first one to solve it, then you get the chance to add the block or mine the block into a blockchain, and you also get a reward for that. That is why you see Bitcoin miners getting 1 Bitcoin or probably what are the Bitcoin days as a reward for mining a block in a Bitcoin blockchain. That is how proof of work works. But the problem with the proof of work consensus mechanism is that it involves a lot of electricity consumption. Your computer solves the puzzle using its computational resources and burning a lot of electricity. So it is not that energy efficient. Second thing is that it is prone to centralization. So a lot of people can come together and in a combined manner can use their computational resources to overpower others and get the chance to mine a block and go with the reward. So there is stronger chances to centralization. And another factor is that there is a high barrier to entry. Only the people with high-end computational rigs get a chance to mine this block and add it into a blockchain and also get the rewards. So to avoid this, we need better consensus mechanism. That is where the second mechanism comes into play. That is called as proof of stake. Proof of stake is a consensus mechanism developed as a solution to the problems that proof of work had. So in proof of stake, we have got validators instead of miners. Okay, so who are validators? Validators are the people or the nodes that tell whether a block is valid or not, whether a block is right or wrong. So how is a person or how is a node chosen as a validator? So you choose a validator by using something called as staking. So if you want to become validator, you have to buy cryptocurrencies or tokens and you have to stake that as a security deposit. So out of all the people who stake maximum amount of tokens, you choose randomly a person and that person becomes the validator, and that person gets an opportunity to validate and tell whether a block is right or wrong. Okay, that is how validation happens in proof of stake. And here the person is chosen randomly and based on maximum number of tokens that has been staked. Okay, sounds confusing? Let me make it more simple. So it's more of like a raffle ticket or a lottery ticket. So if you want to become a winner, you'll have to buy maximum number of lottery tickets and raffle tickets. And out of the people who buy maximum number of lottery or raffle tickets, randomly a person is chosen. So if you want to increase your winning chances, you'll have to buy more and more raffle tickets or lottery tickets. Okay, so this is how proof of stake works. And why is proof of stake better? Proof of stake is better because it is better in terms of energy efficiency. So here you don't mine blocks using your computational resources. You don't solve puzzles and you don't mine blocks. Rather, you stake something and you validate the block. Okay, and here it is more safe and secure because once you become a validator and you validate a block, if you do it in the right manner, you get the tokens that you have staked back. Along with that, you also get some sort of rewards. So if you do good thing, you get rewards. And consider, if you're not responsible and you validate a wrong block, then you don't get rewards. Also, you lose whatever the tokens that you have staked. Okay, so here the validators are more responsible, and because of that, the entire network remains safe and secure. Okay, and here the barriers to entry is very low because you don't need heavy or powerful hardware like proof of work. Okay, so because of reduced hardware requirements, there is lower barrier to entry. So anybody who has tokens to put at stake can come and stake their tokens and get an opportunity to become validator. Okay, it is more immune to centralization. So here the validator is chosen randomly. Because of that, it is more immune to centralization. So no group of people can come together using their computational resources and mine a block like what happens in proof of work. Also, it has stronger support to shard chains. Okay, it's one of the way used in Ethereum network to upgrade in terms of scaling. DPoS or delegated proof of stake. What is it? In POS or proof of stake, we had validators who stake their cryptocurrencies or tokens to get an opportunity to validate the block. So you might have money to buy tokens or cryptocurrencies and stake that to get an opportunity to validate the block. But you might not have the resources, time, or infrastructure to validate the block. So that is when DPoS or delegated proof of stake comes into play. So here in DPoS, what we do is there are entities in the blockchain network who are ready to become validators. So what we do is we stake our tokens or cryptocurrencies in the name of that person who is ready to become a validator. So there are multiple persons like this who are ready to become validators. So out of this, the person with maximum number of tokens staked gets the opportunity to become validator. Okay, so it's sort of like voting. So the person with maximum number of votes to become the validator gets an opportunity to become validator. Okay, and validates the block. So after validating the block, they get whatever the tokens they have staked in return, along with some sort of rewards. Okay, and the person who has delegated that validator gets a small chunk of reward back along with their staked tokens or cryptocurrencies. Okay, so that is how DPoS works. Still sounds confusing? Then it's more like elections that happen in our country or in our locality, because we don't have enough amount of time, resources, or infrastructure to do the administration and governance. We delegate a candidate to become the minister or the legislative candidate or prime minister, president, and to do all these sort of administration and governance. Okay, that is how DPoS works. To delegate somebody to do the validation process. Bitcoin was actually the first generation of blockchain, and it had all the good advantages that blockchain brought into place, such as openness, transparency, at the same time being trustless and permissionless in nature, so you don't have to depend on any central entity such as bank to do your transactions. But we are not out there on the internet just doing monetary transactions. We wanted to do more. We wanted to solve problems that are out there on the internet, which were far more important and had more seriousness using blockchain. Our internet or a web generation powered by blockchain with all these advantages. That is what we were looking for. That is what sounds interesting also, right? So that was possible through something called as programmable logic. Programmable logic was brought to play in the second generation of blockchain through something called as smart contracts. So you might have heard about this word called as smart contracts recently on Twitter and various other platforms. So what exactly is smart contract is? A smart contract is a piece of code or simply is a program that takes in certain amount of input, and if that input meets certain input criteria, it is programmed to give out output. Okay, it's a very simple program which takes in an input. If the input meets the input criteria, gives out certain output. Okay, and this piece of code or this smart contract or this program lies on a blockchain-based decentralized network. And if still it sounds more technical and confusing, let me make it very simple using something that you're already familiar with. A smart contract is exactly like a Coke vending machine or a Coke dispensing machine. It is pre-programmed to receive certain amount of money as an input. If the price of the Coke is $1, then you have to input or deposit $1. And if the $1 input meets the input criteria, basically, which is the price of the Coke, then the Coke vending machine will dispense a Coke can or a Coke bottle so that you can drink it and enjoy it. Right. So this is what basically a smart contract looks like. And because the smart contract or this piece of code or program lies on a blockchain network, it's not accessible to all in a free manner. So that people don't spam it, we have kept a fees for it. So if you have to access this piece of code, piece of program or smart contract and get the desired output, first you have to pay a small amount of fees, which is basically called as gas fees, or it is the transaction fees to access this piece of code or program or smart contract and get whatever the desired output you want. And if you ask me what makes a smart contract a different or stand apart from the traditional program, is the fact that because it is on a decentralized blockchain based network, you don't have to depend on any central entity. It's completely automated. After you given certain input, and if the input meets the input criteria, you get the output. You don't have to get permission from anybody. You don't have to trust any single central entity. So everything is clear, open, transparent, at the same time has trustless and permissionless nature. So whatever the good advantages that blockchain had, it was brought into play to solve far more important and far more serious problems through programmable logic using smart contracts. So you can program a lot of things using smart contracts, and you can automate all these things, and it runs on a decentralized blockchain network. Now that you know what smart contracts are and what is the similarity between a smart contract and a vending machine or dispensing machine, let's shed some more light onto this topic and understand where actually these smart contracts are used. So to be honest, smart contracts are actually like the internal machinery of a vending machine or dispensing machine. It consists of all these mechanical parts and electrical wiring that allows you to input money and get the Coke can or bottle dispensed. So it serves its purpose, but it's not that easy to use. I don't think so a normal user would be willing to go and use a vending machine which has all these mechanical parts and open electrical wiring. So that is why the manufacturers of this vending machine have built it with a proper enclosure and interface consisting of the place to put money, buttons to operate, and a place to get the can or bottle dispensed. So we need a user interface or an interface through which we can access the machinery which provides you with the functionality. So a Coke vending machine or a normal dispensing machine isn't just the machinery that provides you with the functionality, but there is a combination or it's a package of machinery with functionality along with an interface that allows you to access this machinery. So it's not just machinery, but it's a combination. Similarly, a smart contract is a raw piece of code which a developer or a programmer might be able to use or interact with, but I don't think so normal audience or user would be able to interact with the smart contract or just a raw piece of code. So that is where we need a user interface through which a user can interact with the smart contract and get whatever the desired output is. So we built this front-end user interface using front-end frameworks such as React, Vue, or Angular, and combine that with the smart contract. Smart contract provides you with the logic or the functionality for the application to work, and the front-end user interface provides you with the interface to access the smart contract. So when you combine both, you get an application or a package. Okay. Then what you do is, then you deploy this package or application on a decentralized network. And that is when this application is called as a DApp or a decentralized application. So what is a DApp or a decentralized application? It is a combination of a smart contract and user interface deployed on a decentralized network. So if you ask me what makes dApps unique from the traditional applications, is the fact that it doesn't run on centralized servers. It runs on decentralized networks. So what is the advantages of applications running on decentralized networks? It has a zero downtime. It is more robust and reliable, easily available at all times whenever you want to use or access it. It has better privacy, all thanks to blockchain. It is censorship free. It has complete data integrity. That means whatever the data that goes into this application or on this network is tamper proof or nobody can manipulate it. It's safe, all thanks to complex cryptographic algorithms. and it has verifiable behavior. So smart contracts are pre-programmed to receive certain input and give out certain output. So you can be very sure, you can predict how the application will work. So this all things are what makes a dApp unique from the traditional applications. Now you know what exactly blockchain is, what dApps and smart contracts are, what is a decentralized peer-to-peer network. So what is the relationship between blockchain technology and Web3? But before that, what exactly is Web3? Curious? Let's look into that. So Web3 is the current generation of internet or the future generation of internet into which we are entering at the moment or transitioning at the moment. And this Web3 is completely decentralized or distributed. It's not owned by any giant technological company, but it's owned, controlled, and managed by the users of the internet. We are the ones controlling, managing, and using it. And blockchain is one of the technology that powers this Web3. But what was the need for Web3? For that, let's understand the problems and caveats that the first generation and second generation of internet had. Web 1 or the first generation of internet was read only. So the users were only able to consume content. Then there came Web 2 or the second generation of internet, which allowed users to not just consume content but also create content. That is read and write. Then there came Web 3, which allowed users to not just consume and create content but also own it. So Web3 is basically the internet of the people, by the people, for the people. So it helps the users of the internet regain complete control. So there are a couple of things that makes Web3 distinctive. Let's look at that. Web3 is also known as the money layer for internet because in the previous generations of internet it was very difficult to do monetary transactions without trusting these central entities. And all these transactions were opaque. We couldn't verify or monitor it. But with Web3, because of blockchain technology, all these transactions are transparent. Anybody can monitor and verify these transactions, which prevents any sort of fraudulent activities or transactions or scams from happening. And cryptocurrencies is what makes this possible. And there are people like or entities like miners and validators who ensure that everything is going right in this network. Then what? Web3 is also an identity layer for the internet. That means each and every user on the internet has their own identity. And with Web3, they can decide what part of their identity they reveal and what they keep private. So they have complete control over the data that they share with any platform or any application or any service. Also, Web3 is a reaction to the problems that we faced in the second generation of internet. We had an extractive relationship with all these apps, platforms, and services that we are using in Web 2 or second generation of internet, where they were stealing our data. We did not have control over what we were sharing with them. They were the ones deciding, and they were earning a lot of money with that. But here in Web 3, we have solved that problem. Here, the users have complete control over their data and they decide what they share with any application, platform, or service on internet. Then what? Web3 is also a creator economy. Here, people were earning for whatever the content they were creating because they own it. A couple of examples are NFTs, proof of engagement, or P2E based games. NFTs allowed artists to create digital arts, which not only allowed them to earn money on selling it, but also on reselling of the NFTs or art. Similarly, proof of engagement or play to earn games made it possible for the gamers to earn money for the time they spent in playing the game. So this was far more beneficial for game creators or the game developers as well as the players or the gamers. So Web3 created a new digital creator economy which valued the presence or the engagement of the users on the internet. Now you know why Web3 sounds so interesting. Let's look at the relationship that blockchain has with Web3. So blockchain is the foundational technology behind Web3. Without blockchain, Web3 won't be decentralized. Blockchain is what gives it the trustless and permissionless nature, at the same time giving privacy to all the users and their data. Also making all the transactions and activity happening on the internet verifiable and transparent. And security and privacy are the two important things that the developers of Web3 is using to appeal to the internet users to start adopting Web3 and Web3 based applications. Now let's look at what Ethereum is. But before that, let's understand what Bitcoin is and what was actually the reason or what was the need for creating Ethereum. Bitcoin is simply an electronic cash system on a decentralized network or blockchain network. That means it allowed users to do monetary transactions on internet without depending on any bank or central entity or a company. And it had all the advantages that blockchain had. And it literally revolutionized the financial segment. And we wanted to revolutionize different other segments on the internet with the same advantages that Bitcoin had because of blockchain. And that is when Ethereum introduced logical programmability through smart contracts, which is something I covered earlier. So now you could write code and run applications or programs or softwares on decentralized network or blockchain network. And this code used to run on something called as EVM or Ethereum virtual machine. So whenever you write a code and deploy it on Ethereum network, it runs because of EVM or Ethereum virtual machine. And also Ethereum virtual machine knows the current state of the entire network. In simple words, Ethereum virtual machine or EVM is the bookkeeper of the Ethereum network. So if you want to compile everything and understand, so Ethereum is simply a platform, a decentralized platform that allows you to run code, run applications, run programs with the same advantages that blockchain had or Bitcoin had. And Ethereum implements proof of work consensus. So whenever you do some transaction, a new block is mined. And also similar to Bitcoin, users get reward here, but the reward is in the form of ETH, which is the currency of Ethereum network. And whenever you do some sort of transaction here, like if you want to run a code or if you want to deploy an application or deploy a smart contract, you basically have to pay a small amount of fees, which is the transaction fees on Ethereum network. And this transaction fees is known as gas fees. This is to ensure that nobody spams the network or misuses the resources of the network. So that's it for this video. I hope that with this video, we have covered all the basics that you require to get started and break into blockchain. And if you think this video will help you have a smooth takeoff into the Web3 space, then make sure to give it a thumbs up, share it with your friends, and subscribe for more such videos. Thank you and see you soon.